Here we have some properties and facts of polynomials that can help you when it comes to graphing polynomials or writing equations of polynomials. So the first thing we're going to look at is facts about the multiplicity. If the multiplicity of a 0 r of a polynomial is even, then the graph of f touches the x-axis at r. If the multiplicity of a 0 r is odd, then the graph of f crosses the x-axis at r. So what does that mean? So here we have the polynomial x plus 1 all squared times x minus 2, and this is the graph of said polynomial. If we look at x plus 1 squared, and we want to find the 0 of this part of the factored form, we just set it equal to 0 and solve. So we can square root both sides, so that's just x plus 1 equals 0, and subtract 1 from both sides, x equals negative 1. Now, this is a 2 here. It's squared, it's even, which means that if it's squared, we just say that it's x plus 1, x plus 1. So if we were to set both of these individually equal to 0, we'd have 2 negative 1s. So when we have the square up here, we can say that this has multiplicity of 2. Because it occurs twice. And because it occurs twice at negative 1, since it's even, the graph will just go up and touch negative 1 and then go down like it shows here on the graph. Whereas we have x minus 2, we set that equal to 0, we're going to get just a plain 2. And this just occurs one time because this has an exponent of 1. So we can say that x equals 2 has multiplicity of 1, meaning it only occurs one time. Negative 1 occurs twice, positive 2 occurs once. And since it occurs only once over here, that means it's odd and it crosses. So if it's an even multiplicity, it will touch at that point on the x-axis. And if it's an odd multiplicity, it will cross that point at the x-axis. Next, we can talk about the turning points. If f is a polynomial function of degree n, then the graph of f has at most n minus 1 turning points. If the graph of the polynomial function has n minus 1 turning points, then the degree of f is at least n. So if we look at again our function here, f of x equals x plus 1 all squared times x minus 2. If we were to work this all out, this would be a degree 3 polynomial, because this is going to be a square here and this will just be linear, so when we multiply together it'll be cubed. So because it has a degree 3, that means it has at most n minus 1 turning points. So we can say that this graph has 2 turning points. And you can see here, as we watch the graph go up, it turns and goes back down. So that's 1, and it's going down, eventually turns again and goes back up. So 1 turning point, 2 turning points. Now, if we were to look at this graph, we can see as it's going down, it turns once, twice, 3 times. So since it turns 3 times, since this has 3 turning points, it's at least a degree 4 polynomial. It could be higher because of different things that could go on, but because it has 3 turning points, we could say that it has at the very least it's at least a degree 4 polynomial. Now we're dealing with end behavior, meaning where it starts and stops. So for larger values of x, either positive or negative, the graph of the polynomial function f of x is this whole thing here. But we're not really concerned with the whole thing. We really just need to know what the leading term is. So the rest of the polynomial is kind of just not necessary for this. We just need to know what it starts off with. And why we do focus on that is because what it starts off with is what it's going to resemble. So if the degree of the polynomial is even, 2, 4, 6, 8, 10, 12, then the shape of the polynomial function will have the same end behavior as the function y equals x squared. If the degree of the polynomial is odd, 3, 5, 7, 9, 11, so on, then the shape of the polynomial function will have the same end behavior as the function y equals x cubed. So if you have forgotten, x squared polynomial starts up high and then goes back high as a U shape, whereas x cubed starts low, goes up, and ends high. So these are the kind of end behaviors you can expect. So we start here, f of x equals x plus 1 all squared times x minus 2. We see there's a 2 here and there's a 1 here. So this is going to have a degree 3. And since it has a degree 3, and it has other stuff going on, but we're only focused on the highest term here, the highest degree. Since it's just an odd degree, it's going to have this shape. And since the leading term here, since it's a positive, it's going to stay in this shape. It's not going to flip. So this polynomial, since a is greater than 0, is going to start low, and then as it goes along, it's going to end high. Whereas this one here, negative 2 times x plus 3 to the 4th, this is a 4th degree, so degree 4. And we can see that its a value here is negative 2, so we can say that a is less than 0, it's negative. It's going to have an even degree, so it looks like this, but the negative causes it to flip. So instead of going from high to high, this is going to go, or this is going to start low and then end low. So this first one is going to be similar to this graph here, starting low and going high. And this one is going to have the similar shape of the parabola, except upside down. So it's going to have this shape instead. Going to start low and then end low.